How's everybody doing? Thanks for coming today. I know it's the last day, so I've expected at least 6 people, so it's nice we have a few more in the room. So because there's not a lot of people, if you have a question while I'm talking, feel free to interrupt me. I'm kind of just going to go over what's possible on the mobile phone, and just one little caveat. You know, WWDC is next week. This is primarily iPhone focused. It all could change. So, you know, Apple could come out with a bunch of new machine learning, or, you know, their object capture API or things like that. So I'm going to try to run through this and do any Q&A for anybody that has any like particular questions. So what we really saw a couple years ago was, you know, the LiDAR all of a sudden said, hey, we can really think about capturing 3D on the mobile phone. But we also have these other, you know, devices, sensors on the phone. We have the TrueDepth sensor on the front. Photogrammetry has become a lot more accessible. There's been open source pipelines. It's improved a lot. Apple released their own object capture API. So I'm going to kind of go over all these little, you know, these little variations and, you know, what's feasible, what works where. So kind of really just starting off, you know, 3D capture's been around for a long time. You know, primarily it had been like photogrammetry from, you know, drones and things like that. We had high precision LiDAR, you know, these $200,000 sensors. You know, you can get like a Leica BOK for like 20K, but there's still a lot. But all of a sudden now people are like, oh wow, we can do 3D capture on our device and we can render it immediately. And you know, we make a 3D scanner app, and there's a few other really great ones out there like Polycam, Metascan, Sitescape, and there's a few others I'm probably forgetting to mention. But when you go to capture something, you should kind of think about like, why am I doing this capture? What am I trying to do? And we try to like divide it up, and we work with people as like in 3 basic categories. Like, are you thinking about precision? Are you interested in measurements? Or is this more informational? Am I just trying to capture the space of the room? Maybe I'm going to use this later in something else, and I'm more interested in fidelity, like really nice textures. Or is it entertainment? And that is like, am I going to use this for, you know, just for fun? Or maybe I'm going to put it in a filter. And then there's a lot of other real considerations when you're thinking about this pipeline, like how much time do you want the user to spend capturing? How large of an area are you scanning? You know, how quickly do you want those results back? GPS accuracy is a huge one. Privacy. A lot of people don't want the data going anywhere. A lot of these cloud renderings, you know, they get sent to the cloud. Lighting conditions is a huge one. And then also, as I just mentioned earlier, do I want this data getting done, you know, remotely? You know, a lot of these apps, you know, they're going off to some machine learning pipeline all over the world, you know, and then there's a huge privacy issue. So again, you know, what I started off with, like, what are we working with? So basically there's 3 kind of inputs, and I'm focused on the iPhone. Android has similar stuff, but because of all the manufacturers, it's so disparate, like what's on each device. So, you know, the main one is we've got the camera. You can get depth information out of that camera because sometimes there's 2, and you know, you can get a little stereography to create a depth map. As of 2 years ago, now we have a LiDAR sensor, and then on the front of the phone we have the TrueDepth. But what's important to consider is that Apple put these devices into their phones to take better photos and videos. They didn't put them in there so you could scan a room or, you know, measure spaces. Even though that, you know, people are utilizing it for that, that's not why they're there, and they're not very accurate because of that. So once we get this capture, then we move into our next layer is like, you know, what data are we collecting on the device? Obviously, RGB images, you know, just a photo. We can also collect depth data with that. When we're capturing with LiDAR, we also get a confidence map. The confidence map means like, how accurate does it think that LiDAR signal was? Like if I'm scanning something like this glass of water, I'm not going to get a very good confidence. It's very reflective. It's not a good material to scan. Also, some paints don't really reflect LiDAR very well at all. And then we have Apple will also, they kind of combine all their sensors in sensor fusion, and they'll give you back a machine learning processed mesh, which I obviously left a typo and put it on there twice. And then the next stage is like, what do you want to do with this data, like on-device processing? So you can reconstruct, you know, that mesh and add texture to it right there on the device. Usually takes, you know, anywhere to a few seconds or minutes, depending on the size of the scan and the resolution. And then afterwards, what we're seeing with a lot of these more improved meshes, we're post-processing that on a desktop computer, or we're sending it off to the cloud and getting it back. So now let's start talking through individual examples. I've kind of given an overview. First thing we're going to go into is photogrammetry. So I've just thrown up here a picture of what a photogrammetry rig does to capture like a high quality person. There's 206 cameras, like DSLR, they're shooting like 20 megapixels. A data set is almost, is a few hundred megs. And that's what you're getting for like really high precision photogrammetry. Same thing when you're getting into like aerial photography. But what's nice, these cameras on these devices have gotten really good recently. So I can take, a bunch of pictures. There's a mushroom there. You can even see like my fingerprint on it. and there's like a fire hydrant. So you can get these really nice high quality reconstructions, but you have to know what you're doing. You have to like understand about image overlap, walking around it. You can't just like point your phone at something, take a couple pictures and expect a good photogrammetry, pipeline. So, a few of the apps, what you're seeing is also they'll guide you through the images collection in augmented reality. And a problem there is currently, and this could change next week, is that the image resolution you get isn't very high. It's 1440 by 1920, while if you take a picture on your phone, it's much larger. So then jumping into LiDAR. This was like the game changer, at least for us. We've been doing photogrammetry and other 3D reconstruction pipelines. When the LiDAR came out, we could immediately see, this is a real-time 3D data capture of a building in New Orleans. It was just so interesting. We got to see what, information in 3D immediately. And then, the other sensor I'm talking about is the TrueDepth. It's a really great sensor, very accurate. You can, certain scan conditions, you can get to like 2 millimeter, even 1 millimeter, but it's really hard to scan. Apple put that sensor on there for your face to do really beautiful photography and obviously Face ID. But, a lot of people are using it to collect other things. I'll get into this later, but we use it a lot for like body measurements and stuff like that. But it doesn't work from very far away. It maxes out really at about 1 meter. You can get information back up to about 1.5, but it gets real noisy. And as that like video is demonstrating, it's really hard to scan when you can't see what you're doing when the camera's backwards. So it's really challenging. So, kind of going into photogrammetry, into TrueDepth, where we're using this, is mostly around body parts. We use this for a bra fitting company to scan torsos, for hands, for like a cast company, for feet, for a couple shoe companies. And so you can get really, as I mentioned, in the 2 millimeter range, after you've trained people how to scan because of the difficulty of scanning, but you can get some really great data. So it really just depends about your use case and what you're trying to accomplish. So here's another client we have. They make self-storage, and what it helps, people to scan all their objects and assemble them. So people want immediately, data back. So in this use case, what we're doing is we're collecting that data with LiDAR, so they have immediate dimensions. And then we're also post-processing it, sending it off the cloud to improve the resolution of the items as well, so they look a little more realistic, because that's what the customer wants. Again, measurements are a real big use for the iPhone now. A lot of companies are using it in different spaces, from measuring window replacements or window shades, how much dirt is in a pile. So it's all about quick capturing, immediately accessing that data and knowing how to use it. Again, it's about, in this case, it's not so much about fidelity, it's about accuracy. And so, LiDAR has been really great there, but again, LiDAR is usually about, 90-something% accurate in the best cases. So, that's, if you're thinking about using this, you got to understand particularly that you're introducing error into your measurements and how to adapt, deal with that. Again, just going into mobile phone LiDAR, really great for like field surveying, going out, capturing data very quickly, putting that on a GPS map, showing what that might look like, and coordinating those resources with other people in the company. So this is like some valves getting replaced underground where they were scanning all the excavations because they're about to get backfilled. Something else just important when you really need to get an accuracy and you want the fidelity of what the iPhone's giving, or the ability to capture and update. This is a castle in Vienna where a high precision LiDAR scan was done, and then as they were doing the repairs, they would go through and scan with the iPhone to monitor the as-built repairs And we would align the iPhone scans to the high precision ones to correct all the geometry issues. But it takes a while like that. I've sped up the video, but it takes about 4 or 5 minutes on the phone, what you're seeing there in a few seconds. So just a quick summary of the things I've kind of been going about. LiDAR, it's quick, it can be post-processed, but you're not getting high fidelity images, so the post-processing will improve it a little bit. Now we're seeing things like machine learning helping out a lot, and I'll touch on that for a quick second later. TrueDepth, it's the best sensor on the phone, but it's limited size, can be really challenging to scan. Photogrammetry, great for capturing large areas, but it's time consuming, requires post-processing, but this is changing very rapidly. The old photogrammetry pipelines didn't include depth in that information, but now Apple's released it, Pix4D's engine can handle depth, and now Capturing Reality, Epic's engine handles depth maps as well. Also something really important about captures to think about is GPS. The GPS radios on these phones are really bad. So if you're in your pipeline and you want accurate captures and you're matching that, you probably want to think about attaching an external sensor, like this is a GPS RTK, that will improve that accuracy and usually get it to about the 30 centimeter range. Also, what's happening a lot now is these visual alignment systems. You probably heard about Niantic talking about their VPS. Google has one too that's really good. It'll mostly works in urban environments, but it'll improve a scan. If you just wave around, look at buildings, you'll see your GPS is usually in the 5 meter range, and it'll get down to 0.3 meters. So it really helps when people are collecting data. We have a couple clients that are using it they scan manhole covers essentially, and then they get much more accurate placements of where those scans exist in their BIM systems. Also, another approach we're seeing a lot is this hybrid. This is the expectation of what people think 3D capture is very high. Oh, I'm going to scan something and I'm going to get something really great. But instead, you get this kind of noisy mesh. What do I do with that? So a lot of people, especially in the interior spaces and exterior, they're getting into hybrid. So they'll take that data, they have it for then reference, and then they are combining that with 3D assets, or they're having people recreate it, or they're turning that into floor plans and recreating synthetic spaces, and you get this really high quality with that 3D capture. Kind of one of the last things I'm going to talk about is the elephant in the room. Everybody's talking about NeRF. What is this? Is this a game changer? Obviously, NVIDIA's here in force. They're promoting things like this. It's very, very cool. But, what is it? Well, it's really rendering out any viewpoint you want. So you're getting a great visual way to convey information, but you're not getting really good geometry out of it. So everybody that's really excited about it, I think it's super interesting, but it's not going to solve all these problems that we have. You're essentially just getting a camera that's giving you a point of view on every space. But who knows, this could change overnight. ML is just moving so fast right now. It's just mind-boggling. Just a few wrap-up notes about me and our company before I jump into Q&A. We've been making iPhone and mobile apps for a long time. We've had a bunch at the top of the store, but we've also had a million failures. We're just constantly prototyping. We do work for big companies and small. And it's this 3D space is just super exciting for us and what's possible with the mobile phones. And the company's really just me and my brother. That's why we've named it after our last names. And thanks again for everybody taking the time and showing up. I know it's the last day. It's a little tough to make it to these things sometime. So I was going to jump into Q&A. If anybody had some specific questions, I can share our experiences and challenges we've had. I'm running the Q&A, I think, because the guy had to run. So does anybody have a question, feel free to jump up to a mic.
Thank you very much for the talk. I was wondering, have you ever compared how much computational power is required if you're only using spectroscopic cameras and then trying to create a 3D image from that compared with the depth camera, for example, LiDAR or time-of-flight sensor?
Well, the stereo camera, creating a depth map from two cameras, yes. That's what you mean? Those depth maps can be, but they're not nearly as accurate as structured light,
I was more interested in, for example, for AR, VR, power is a big factor. So I wanted to ask you, have you ever compared a full power comparison? Like if you compare the how much power it takes for the cameras plus the computational power and compare them with the time of flight, apart from accuracy, just purely from power.
Well, for the work we do, keep in mind that the sensors are doing a lot of the computation themselves, so it's not, you're not just offloading that directly to like, the main chips. So that's a really tough question to answer without knowing this particular hardware stack.
Okay,
If
thank
that
you.
makes sense.
Okay, thanks.
Hey, thank you very much. With WWDC around the corner, you mentioned, obviously, Apple LiDAR's release was kind of a watershed moment for this technology. What, in your opinion, would be next? What are you most excited about potentially happening? What could be the next Apple LiDAR for all of us as content creators?
I mean, I'm not entirely sure Apple's going to continue to invest in LiDAR. The TrueDepth sensor on the iPhone 13 is a little bit more degraded than the one on the 12. So it's like, who knows where this is going? Again, they put it in there for video, and that's what they're very focused on. Obviously, there's a lot of us that have leveraged on that device and hacked things, but I think they're most interested in fidelity reconstructions, and that's where you're seeing, RealityKit and their object capture API just taking really nice high-resolution images and reconstructing that. So, that's my guess. I think they're going to keep the LiDAR sensor around in the device, but it may become a cost comparison thing and they'll just drop it. But I'm hoping they're keeping the pro models around, but I don't see them increasing the resolution or improving that sensor. Again, that's just my guess.
Hey, Jason. Good talk, by the way. Just a quick question for you is, when you talk about object capture and photogrammetry and things, it's kind of like capturing around an object, and we need to capture a room. So I'm just wondering, how well does photogrammetry work there, or the inverse of object capture versus room capture?
That just depends on your photogrammetry pipeline. What it's optimized for is, as object capture says in the name, Apple has optimized that engine for capturing objects and rendering that, because they're thinking about bringing 3D content into their universe. You can optimize different pipelines. I should have put a slide in there, but people have done some great reconstructions of spaces. But again, with the problem with photogrammetry is like windows and highly reflective surfaces, you're not going to reconstruct them that well. Like, what people always show off in photogrammetry are really great surfaces like rocks and textures and things that aren't reflective. You didn't see me showing off scans of glass bottles.
Yeah. Okay. Yeah, thank you. That makes sense.
Any other questions? All right. I kind of ran this talk quick because I was thinking people would be more into Q&A as it developed. Okay.
Thank you for the talk. My name's Elias. I had a couple quick questions on recommendations for higher quality. So you're saying not to trust the LiDAR on the iPhone. What are some, I guess, a range in terms of consumer viable and then, I guess, professional level LiDAR outside of the mobile phone?
I mean, like, what do you mean by higher quality? Better fidelity or better accuracy?
Better accuracy.
Better accuracy. This, that example I tried to show, you're going to get that from photogrammetry, but you need that depth map to give yourself really good scale. So high quality images and like that technology is really well developed. And if you take enough images, you can get really good accurate reconstructions, but they're still going to be off a little bit. A lot of people, in the more professional realm, when they're doing that, they'll put down ground control points so that they, we know this is 3 meters away from this image, from that image, and then they can, correct that. And you see that in a lot of drone surveying and things like that. Is there a particular thing you're trying to capture, or?
Well, I've done a couple of different projects, developing anatomy models and creating, virtual versions of them. In the past, I've started with photogrammetry and then taken it into ZBrush and cleaned it up myself.
Oh, nice.
So I would like to not have to do that, but
I think we're a ways from even using those, like that high-end system I showed you, that goes through a retopology stage. So, there's an artist sitting there cleaning all that up, optimizing those mesh and that texture. So we're all hoping machine learning is going to fix all this stuff, but that could be still years away.
okay. Thank you so much.
Thanks for the talk. I'm wondering, what are you seeing as like the biggest use cases of mobile 3D scanning?
It's really all over it. I mean, all over the space. I think the biggest thing we're seeing right now is really people trying to capture rooms in real estate. Real estate is really driving that. But as we talked about earlier, it's hard to get, you know, like a square room with no windows will capture great. But, you know, a typical house that has windows all over the place and has, you know, stainless steel sinks and stuff like that, you know, that is really challenging. So, you know, everybody wants to capture something and, you know, create a floor plan out of that, turn that interior design, and there's a lot of people working on this right now. Like Apple's working on that. You know, that's part of like their HomeKit project, that you scan your house and it knows where all your smart devices are and you have a floor plan. So, I mean, that's my hope, that Apple will continue and invest in improving the hardware, because they want us to understand our physical and, you know, virtual space, you know, and obviously the big investment in AR.
Thanks.
Anybody else?
One last question. How Pixel does their scans?
Well, I mean, most of their scans, from what I like the mega scans, that's all photogrammetry. You know, so they're taking super high resolution images, and, you know, obviously that's why Epic owns capturing reality. Anybody else? We have 3 minutes left, or I can wrap it up. I know we're probably all tired. All right. Well, thank you. Thanks for coming. I appreciate everybody coming.